of a function. Okay, so today we are going to study about differentiability of a function. Okay, draw x-axis, draw y-axis, and let's consider a function y is equal to f of x. Now we will draw the plot of this function y is equal to f of x. This is any general function. Okay, so we have drawn the plot of y is equal to f of x. Now let's consider a point on the x-axis, and that will be m c comma 0. Okay, now what is the meaning of c comma 0? It means that the distance of m from y-axis is c unit. Okay, now if the x coordinate of the point m is c and my function is y is equal to f of x, then what will be my y coordinate? It will be f of x. In place of x we have to put c, so that will become f of c. Okay, yes. So what will be this function? F, what will be this height? This will become f of this height will become f of c. Okay, now we will plot this coordinate as an ordered pair, x coordinate comma y coordinate. So it will become c comma f of c, and we call this as a point P. Now we will define the derivative of the function as a d of y divided by d of x, and that is equal to f prime of x, and x is equal to c. Means we are finding the derivative of this function at x is equal to c. Okay, that we have to find the derivative of the function at the point P whose coordinate is given as c comma f of c. Okay, so what will be the derivative? Its derivative will be this tangent line. Okay, what is the meaning of this tangent line? Means this is a line that will touch the curve only at a one point at point C. So it is touching the curve at a point C. Okay, so that is the meaning of derivative of the function. So what is the derivative? Derivative is the slope of the tangent which is only touching the curve at one point, and that point is my ordered pair c comma f of c, and that point is P. Okay, so as we said that this d of y, as we said that d of y divided by d of x at a point C is nothing but the slope of the tangent. And how we define the slope of the tangent? We define the slope of the tangent as tan of theta. Okay, tan of theta is equal to perpendicular divided by base. What is the perpendicular here? Perpendicular is this line f of c, and what is the base? Base is this line. So we don't have to find perpendicular divided by base as tan of theta, but rather we will simply calculate d of y upon d of x. We will simply calculate d of y upon d of x. Now let's move further. Okay, so as we said that d of y upon d of x is nothing but it is the slope of the tangent at the slope of the tangent line t. Okay, at a point P whose coordinate is c comma f of c. Now we will see the proof of the differentiability. Okay, so let's consider a function y is equal to f of x. Now we will plot it, y is equal to f of x. Now let's consider a point C on the x axis. Then we will define f of c as the height at point C of the function. Okay, so that will become f of c. Now we will obtain the ordered pair as P of c comma f of c. Okay, now we will move c h units forward. हम लोग क्या कर रहे हैं? We are moving h units forward. Okay, so we have moved h units forward. Now tell what will be the coordinate of the new point. So it will become c plus h. X coordinate will become c plus h. Okay, so x coordinate will become c plus h. Now what will be the height of the function? According to this formula, since y is equal to f of x, so height will become, in place of x, what will come? C plus h. So height will become f of c plus h. So that will be my height, f of c plus h. Okay, so we have obtained a point Q whose height is f of c plus h, that is a y coordinate here, and its x coordinate is c plus h. Okay, so height is f of c plus h. So this height will become f of c plus h according to definition of the function. Remember, as this function will change, for example, this is a sine function, then what will be the height? Sine of c plus h. If it will be a cos function, what will be the height? Cos of c plus h. If it is the exponential function, what will become height? E raised to c plus h. And if it is a log function, what will become the height? Log of c plus h. So function will keep on changing, but here we are considering any general function. It can be a log function, it can be exponential function, it can be sine function, it can be cosine function, it can be any function. Okay, so what will be this height? Okay, what will be this height? Yes, the blue green height. So that will become f of c plus h minus f of c. Okay, because the whole height is f of c plus h, and this small height is f of c. So if we do f of c plus h minus f of c, then we get this blue height. Okay, green light green height. It is a light green color. Okay, light green cover is light green color. Height is f of c plus h minus f of c. Okay, yes, so that light green color is f of c plus h minus f of c. Okay, now what will be my base? This base will become h. This base will become h. Okay, and this height is f of c plus h minus f of c. Okay, now we have been given a secant line, that is p of q. Okay, now you can see that the hypotenuse is my secant line. Why? Because we are forming a right angle triangle, and this right angle triangle will be what? Yes, this right angle triangle will be what? This right angle triangle will be QPM, right angled at M. Okay, it will be QPM, right angled at M. Now what will be the slope of the secant line? The slope of the secant line, that is PQ, will be equal to what? That will be equal to perpendicular divided by base. Okay, so what will be my perpendicular? This is my base. Okay, and this is my perpendicular. Okay, so perpendicular divided by base will be the slope of the secant line, that is PQ. Yes, this is perpendicular, this is perpendicular divided by base. Okay, now what is the differentiability of the function? This is d of y upon d of x, that is equal to f prime of x at x is equal to c. So that is equal to slope of the tangent at point x is equal to c. Now what I will do, yes, this will be my tangent. Okay, now here comes the application of the limit. First we will find the slope of PQ, that is the slope of the secant line, and then under the limiting condition where h is tends to 0, we will see that the q will tend to p, and the slope of the secant line, that is a QP, will become the slope of the tangent line. Okay, so how that will happen, we are going to see further. Now the slope of the line PQ, what will be the slope of the line PQ? So slope of the line PQ must be equal to perpendicular, that is this green light, divided by base, that is a yellow base. Okay, so perpendicular is f of c plus h minus f of c. So that is my perpendicular, and what is my base? Base will become h. So I will write the slope of the PQ line as, I will write the slope of the PQ line as what? Perpendicular divided by base. Okay, that will become perpendicular divided by base. So that will become f of c plus of h minus f of c divided by h. Okay, perpendicular divided by base. Okay, now under the limiting condition, you assume that h is becoming smaller and smaller and smaller. So as the h will become smaller and smaller, what will happen? Q will start moving closer to point P. What will happen? That the Q will start moving closer to the point P. Okay, when h will become smaller and smaller and smaller, and ultimately when h will tend to 0, what will happen? That the Q point will become almost P point, and this PQ ka slope, the slope of PQ will become the slope of this tangent line at P. So what we will do, we will take the limit of f of c plus h minus f of c divided by h, where h is tending to 0, and that will become the derivative of what? The function. So we can define d of y upon d of x as limit of h tending to 0 times f of c plus of h minus f of c divided by h, where h is tending to 0. Now we will see this through animation, okay, how that is happening, how the QP line is, how the slope of PQ line, that is the secant line, is becoming the slope of the tangent line when Q is tending to P. Now remember, when Q will come closer and closer to the P, what will happen? When Q will come closer and closer to the P, what will happen? H will tend to 0. So as we start the H tending to 0, what will happen? That the slope of PQ line, that is the secant line, will become the slope of the tangent line. Okay, this is a tangent line. Now let's see the proof. Yes, so here we have been given a secant line PQ. Now the coordinate of P is c comma f of c, and the coordinate of Q is c plus h comma f of c plus h. Okay, now here we have formed a right angle triangle QPM, right angled at M. Yes, so we have formed a right angle triangle QPM, right angled at M. Now we will calculate the slope of the secant line PQ. So what will be the slope of PQ? That is equal to perpendicular divided by base. Here my perpendicular is f of c plus h minus f of c, and my base is h. So simply I will calculate the slope of the secant line, and what will happen as h will tends to 0. Just see what is going to happen when h is tending to 0. So h is becoming smaller and smaller. Okay, yes, see, h is becoming smaller and smaller. Okay, h is becoming smaller and smaller, h is becoming smaller and smaller. So we see that as the h is becoming smaller and smaller, here just see, the slope of PQ line will become the slope of the tangent at point P when h is tending to 0. So when h is tending to 0, point Q will become point P. Again observe this animation. Yes, so almost Q is tending to P and h is tending to 0. Then what we are seeing, that the slope of the secant line PQ line, the slope of the secant line PQ line is becoming the slope of the tangent. Just see. Yes, the slope of PQ line, that is secant line, is becoming the slope of the tangent at point P when h is tending to 0. Very clear? Q is tending to P. So as Q is tending to P, what is happening? H is tending to 0. So as h is tending to 0, the slope of the secant line, which is here, this is the slope of the secant line, f of c plus h minus f of c divided by h. This is the slope of the secant line. Now under the condition when h is tending to 0, what will happen? When h is tending to 0, Q will tend to P. Yes, so so what is the slope of the secant line? The slope of the secant line, that is a PQ line, is f of c plus h minus f of c divided by h. But under the limit when h is tending to 0, what is happening? Q is tending to P. Yes, so under the condition when Q is tending to P, what will happen? That h will tend to 0, and that is happening in this formula. So now you will be able to understand this formula, why I am taking limit of h tends to 0, and this definition here will become the definition for the derivative d of y upon d of x. So now we will define d of y upon d of x as f prime of x at point x is equal to c as f of c plus h minus f of c divided by h, where h is tending to 0. Now when h is tending to 0, what will happen? That the PQ line, which is the secant line, will become the tangent line. Okay, so h is tending to 0 means Q is tending to P, and the secant line, which is the PQ line, is becoming a tangent line. So from henceforth, what we will say that the derivative of the function is nothing but it is a limit of h tends to 0 times f of c plus h minus f of c divided by h, or you can say f of c plus h minus f of c divided by h, which is the slope of the secant line under the limit when h tends to 0 will become the slope of the tangent line. Now we will use this first principle to find the derivative of a function. Okay, so we can calculate the derivative of function like sine function, cosine function, hyperbolic function, parabolic function, exponential function, log function. All the derivative can be calculated using this very particular formula, f of c plus h minus f of c divided by h, where h is tending to 0. So let's calculate the derivative of hyperbolic function. Y is equal to f of x is equal to 1 upon x. Okay, so in place of f, what we are going to put? So in place of f, what we are going to put? In place of f, yes, now the function f will become 1 upon x. So what we are going to do here? So here f of c plus h will become 1 upon c plus h, and f of c will become 1 upon c. So replace here. So here the function y is equal to f of x is equal to 1 upon x. So we will apply the formula. Yes, so y is equal to f of x is equal to 1 upon x. So here the limit of f of c plus h minus f of c divided by h, where h is tending to 0. So here replace f by 1 upon x. So here it will become 1 upon c plus h minus 1 upon c divided by h, where h is tending to 0. Now to solve this, so c minus of h divided by c plus h times c into 1 upon x. C and c will be cancelled out, and now you will be left with h, c and c will cancel out, minus of h divided by h, so it will become minus of 1. So minus of 1 divided by c plus h times c, where h is tending to 0, so it will become, denominator will become c square. So minus of 1 upon c square. For any general point, c is equal to x. Now if in place of c we will put any general point x, then the derivative of 1 upon x will become minus of 1 upon x square. Okay, so same definition that we have used by the first principle. Similarly, we can find the derivative of x raised to n plus 1 divided by n plus 1. So that is equal to x raised to n. So derivative of x will become 1. What is the derivative of sine x? That is a cosine x. So similarly, applying limit of f of x plus h minus f of x divided by h, where h is tending to 0, we can find the derivative of sine x as cos x. Similarly, we can find the derivative of cos x is minus of sine x. Derivative of tan x is secant square x. Derivative of cot x is minus cosecant square x. What is the derivative of secant x? It is the secant x tan x. What is the derivative of cosecant x? That is equal to minus of cosecant x times cot x. Now remember, all this derivative can be found using the formula limit of f of c. Now c is a specific point. Replace that specific point by x. So that will become f of x plus h minus f of x divided by h, where h is tending to 0. So what is the derivative of sine inverse of x? That is equal to 1 upon square root of 1 minus x square. What is the derivative of cos inverse of x? That will become minus of 1 upon square root of 1 minus x square. So all these derivative can be found using the first principle. Okay, limit of f of x plus h minus f of x divided by h, where h is tending to 0. So we will see all these proof in the coming classes. What is the derivative of tan inverse of x? That is becoming 1 upon 1 plus x square. Derivative of cot inverse x, minus of 1 upon 1 plus x square. Derivative of secant inverse x is equal to 1 upon x times square root of x square minus 1. What is the derivative of cosecant inverse x? That is equal to minus of 1 upon x times square root of x square minus 1. Remember, when the c will come here, then the minus sign will come here. Derivative of e raised to x is e raised to x, and the derivative of log x is 1 upon x. In my In my coming class, I will prove all these derivatives using the first principle by applying the formula of the limit of f of x plus h minus f of x divided by h, where h is tending to 0. Thank you. Join my class. My contact number is given and the monthly fees is only rupees 1000. So please like